we're going to crack straight back on with the question practice. But first, let me just put the Menti code in the chat. So it is 75808169. 75808169. And if you could just let me know in the chat, or actually, maybe it actually tells me how many people are in. I think maybe it does. But yeah, just go and do that now, and I will get the slides up. Oh, I know what the problem is. Okay, cool. So, hopefully everybody is in the Menti. I'll just give you another few seconds in case anybody isn't. But yeah, I'm just opening up the chat on my phone so I can see that at the same time. Okay, so if you have any problems accessing that, just drop a message in the chat or just say on your mic. And but otherwise, I'm going to assume that everybody is on there. And if you are on there, you should see that it says airline pilot, which is this question that is on the screen share at the moment. So I'm going to give you 2 minutes for this question. Off you go. Okay, we're just coming up to 2 minutes now. So get your answers in. Okay, so I'm going to assume that people are still working on it. But if you are completely stuck and do not need more time, then do let me know. Because then I'll just go through the question. Okay, I'll give you 1 more minute. Okay, 30 seconds. Okay, so get your answers in now. Even if it's just a guess, just have a go. And then I'm going to tell you the right answer. So the correct answer is D. Okay, so no one got that one right, so we'll take a bit of time to go through it and make sure everyone understands. So let's just make this a little bit smaller and let's get our calculator over here. So this is one of those questions where they really throw a lot of information at you, and a lot of what you need to do is just eliminate the irrelevant information. So an airline pilot flies an average, and then it tells us how many miles per year, and it tells us this is on international routes in the Type 1 aircraft. Okay, and if you look at this table in this graph, you can immediately see we've got Type 1, Type 2, Type 3, Type 4. And on this graph here, we've got domestic flights and international flights. And so immediately we can start to pick up on the fact that we seem to be focusing on Type 1 aircraft and international flights. So we can start to rule out some of the information that we don't need. It says, what is the predicted cost of fuel over a 1-year period? Okay, so let's see, what information do we have about Type 1 aircraft on international routes? Well, we have the aircraft fuel consumption in miles to the gallon. And we can see that for Type 1 on international, which is what we've got here, it is 8 miles to the gallon. Okay, so every gallon of fuel takes it 8 miles. Or in other words, every 8 miles that it travels, it uses up 1 gallon of fuel. We can also see some information here about Type 1 aircraft. Now, it's unlikely we're going to care about the release year because there's nothing in here about number of years or anything that have passed since it was released. It's unlikely we're going to care about maximum speed, but fuel cost is going to be relevant because the question is about cost, predicted cost of fuel. Okay, so at the moment, we have the number of miles that it travels in a year. We have the number of gallons of fuel, the number of miles that it has to travel to use up 1 gallon of fuel. And we have the cost of 1 gallon of fuel. Okay, so what we want to do is first, from the number of miles it travels per year, we want to work out how many gallons of fuel does it use per year. And we're going to do that using the miles to the gallon value of 8 miles to the gallon. Because then once we know how many gallons of fuel it uses per year, we also know the cost of 1 gallon of fuel, £50.25. So we just multiply that cost by the number of gallons, and then we get the total cost of fuel for a year. So how do we figure out the number of gallons used in a year? Well, what this is telling us here is that every time it travels 8 miles, it uses up 1 gallon of fuel. Okay, so 8 miles of distance covered causes it to consume 1 gallon of fuel. We want to know how many gallons does it cover, how many gallons does it consume when it travels 1,012,500 miles. So what we really want to know is how many 8s are there in this number here. Because you can think of this total distance of 1,012,500 miles as being made up of lots of 8-mile distances. And each of those 8-mile distances consumes 1 gallon of fuel because it's 8 miles to the gallon, 8 miles per gallon. Okay, so we want to know how many lots of 8 miles are in here. So we need to do a division. So we divide the total number of miles by the number of miles that uses up 1 gallon, which is 8. And that tells us that in the course of this year, it's going to use 126,562.5 gallons of fuel. Okay, well then we just multiply that by the cost per gallon. So if each gallon costs £50.25, and we know how many gallons were used, then we just multiply that by £50.25, and we get 6,300,000 £359,765.63, which is D. Okay, so hopefully that makes sense. Let me know if you have any questions. Otherwise, we'll move on to the next question. So let me just move the Menti along. Okay, so have a go at this one. I'm actually going to give you 3 minutes for this one because I know this is quite a tricky question. So off you go. Okay, so you asked what is the volume of the water for one of the bottles? So it doesn't tell you the actual volumes in milliliters, like how many milliliters of volume is it? Because this question is just to do with proportion. So actually, it doesn't actually matter what the actual numbers are. You just need to know the ratios between those numbers, and then you can work out the resultant ratio. Okay, so I'm going to go through this one now. The correct answer is D. And this is a really hard question, I think. So probably one of the hardest ones that we've come across. So I want to make this a bit smaller and then get rid of that one. And then let's actually open up one of these. Okay, so we've got these two bottles, and it tells us this piece of information at the beginning is really crucial. So the bottles are the same volume. If they weren't the same volume, we wouldn't be able to work this out. So I'm going to represent the volume of the bottles with just a rectangle. Let me make that a bit smaller. Okay, and let me actually... Okay, so this is the first bottle, and then the other one is identical. So this just a very abstract way of representing the volume. So this rectangle represents the total volume of each bottle. Okay, now the first bottle, so they both contain a mixture of paint and water. In the first one, the ratio of paint to water is 5:8. Okay, so let's get that a bit smaller. P to W is 5:8. Okay, that's the paint to water ratio. So we could represent that by drawing a line, just roughly speaking, to show that it's 5 parts paint to 8 parts water. And obviously the paint and water wouldn't actually be in separate bits of the bottle. It's just a mathematical representation of the ratio of paint to water. It's just a visual way of showing that ratio. Okay, and in the other bottle, the ratio of paint to water is actually 7:19. Okay, so let me just change that. 7:19. Okay, and so similarly, we can do a little visual representation of that ratio. And we actually put those numbers on here. Okay, so we could think of this, so then we could like combine these two together into one volume. And what I'm actually going to do is let's do a different color for the paint. So let's make the paint purpley pink, pinky purple. Okay, and let's do the same thing here. Okay, cool. So now the paint is the purple color, and the water is the white color. Okay, so when we combine all of this into one bottle, what we get is effectively this. We get one bottle that now has all of this in it. And now what we have to ask ourselves is, what is the ratio of paint to water in this final bottle? Now you might say, okay, well there's 5 parts paint plus 7 parts paint, so that's 12 parts paint, and there's 8 parts water plus 19 parts water, so that's 27 parts water, but that would actually be wrong. And the reason that would be wrong is because these parts over here are not the same size parts as these parts over here. So what I mean by that is that here, the total number of parts is 13, right? So 13 represents the total volume. And over here, the total number of parts is 26. So 26 represents the total volume. But remember that the total volume in reality is the same in both bottles. So if we're using 13 parts to represent that volume here, and we're using 26 parts to represent that same volume over here, then these parts over here must be smaller. Okay, so therefore we can't just combine them together because they're different sizes. So just to give you a kind of visual representation of that, the whoops. This is going to be very rough. Okay, so this kind of, you can see that we've divided this one up into 5 parts, and in fact, let's keep going. 1, 2, 3, 4, 5, 6, 5, 6, 7, 8. So yeah, I've not really distributed those very evenly, but basically the point that I'm getting at is that we split this up into 13 parts. Now, if I went and did the same thing for this one here, which I'm not going to do just to save time, we would have to split it up into 26 parts. And so obviously those parts would end up being much smaller than these ones. So what we need to do is we need to actually split both bottles into the same total number of parts. And we need to do that by using equivalent ratios. So this at the moment adds up to 13, and this at the moment adds up to 26. So you might notice that 26 is actually just 13 times 2. So if we double the 5 and the 8, we get 10 to 16. And that is an equivalent ratio of 5 to 8. It's actually the same ratio as 5 to 8. It's just written using different numbers. But we haven't actually changed the ratio. We've just used different numbers to express it. And therefore, we're allowed to do that. It's an equivalent ratio. And the advantage of doing that is that now it adds up to 26. And this one also adds up to 26. So now the parts that we're dividing this bottle into are the same size as the parts that we're dividing this bottle into. So if we now update these numbers here, we can say that this first bottle is 10 parts paint and 16 parts water. And the second bottle is 7 parts paint and 19 parts water. And now those parts are the same size parts all across both bottles. And therefore, we're talking in the same language when we use the word part over here and when we use the word part over here. Okay, so now all we have to do is add these numbers together. And we can see that the number of parts of paint is 10 plus 7, which is 17. So paint to water, again, 17. And the number of parts water is 16 plus 19, which is 35. So the ratio is 17 to 35, which is D. So hopefully that visual explanation helps to explain that question. As I say, I do think that is a very hard question. I think most of the ratios questions that we'll come across will be generally a bit easier than that. But yeah, hopefully that makes sense. Let's move on to the next one, and I'm going to update the Menti. Yeah, so that you should have a new Menti question with 5 options, and I'll give you 2 minutes to do this one. Off you go. Oh, Tina, the Menti is, I'm going to say it out loud, 75808169, and I'm also going to type it in, 75808169 at menti.com. Okay, get your answers in now. Okay, so the correct answer is C. So well done to the person who got that right. 2 people got that right. 3 people got that right. Excellent. Good. Okay, so we won't spend long going through this one then. And by the way, that's a good principle for learning in general, even when you're teaching yourself, is spend lots of time on the things you're bad at and little time on the things you're good at. So obviously, well, maybe not obviously, but the largest difference between highest and lowest price. So again, the key thing here is identifying the relevant information in this sea of overwhelming information, which is something that just you will get better at with practice. So maximum price, minimum price, we just calculate the difference, which in each case is maximum price minus minimum price. And we don't even have to work out which one's the more positive and more negative because it's already maximum and minimum. So it's always going to be this one minus this one. And if you do that for each one, then you'll see that the one in the middle has a difference of, I think, 713, which is bigger than all the other differences. And it is often a good idea to write all these numbers down as you go along because sometimes the next part of the question actually requires you to do some of the same calculations again. And so obviously if you've got it all jotted down, it will actually save you time in the long run. Okay, great. So moving on then. Let me just move Menti on. Okay, so 2 minutes for this one. Off you go. Okay, that's 2 minutes, so get your answers in. I'll give you another few seconds. Okay, so the correct answer is B. So well done to the person who got that right. So let's have a look at this. So the driver travels an average of 4,250 miles per month, driving only along motorways in an X-Tam car. What is the predicted annual consumption of fuel in gallons? Okay, so this is another kind of miles per gallon question. So maybe we should actually take a little bit more time over this one, since maybe this is something that people find difficult. So let's break this down a little bit. What I might actually do is grab a screenshot of this and then see if I can paste that. Oh, very big. Let's make you smaller. And then let's see. Okay, so then we can annotate on here. Okay, so first of all, we've got 5 different makes of car, but the question is only asking about the Xtam car. Okay, so we can immediately hone in on the Xtam car. We can ignore the rest of the cars. So, and we have maximum speed and cost to purchase. Neither of those pieces of information actually turn out to be relevant to this question. What we need is this information here. And in fact, the question is saying the driver only drives along motorways, and motorway driving is this one here. So we actually only need this piece of information here. Okay, so we're told the number of miles per month. We have the miles to the gallon, and we're asked the annual consumption of fuel. So this is another slightly tricky thing because the data here is per month. Oh, sorry, the data here is per month, but the question is actually per year. I'm actually going to get rid of this because we don't need that information. Now, another slightly tricky thing is actually reading this graph, because very unusually, this graph, well, it goes up in 5s, which is not unusual, but it doesn't go up in multiples of 5. It's 28, 33, 38, and so on, which some could argue is not a very good way to set out a graph, but that's what we've got to deal with. So we can assume that, well, we know that the distance between here and here is equal to 5. And so how many fifths along is it? Well, it looks like it's 1/5 along, so that's a value of 1 above this line. This line is 33, so therefore it's 34. So the figure that we need is 34 miles to the gallon. So 34 miles per gallon. Okay, now we also know that the driver drives an average of 4,250 miles per month. Sorry, that's just bothering me. That is a capital M. Okay, so we have 4,250 miles per month. Now, eventually we want to get an answer per year. So if we wanted to, we could just times this by 12 now and work out how many miles per year, and then we could work with that. That's a good way to do it. But equally, we could work out how many gallons per month and then multiply that by 12, and then we'll have gallons per year. So either way is fine, but I'm going to do it the second way. So the question that we have to ask ourselves is, if the driver drives 4,250 miles in a month, I'm actually just going to change this to in a month, just to make it a bit different to the other one. And the car does 34 miles per gallon, then how many gallons will be used in a month? And then once we times that by 12, we'll get gallons per year. Okay, so there's actually 2 different ways that you could think about this. And I'm going to show you, the one way you can think of it is in terms of ratios. So 34 miles per gallon, that means the ratio of miles to gallons is 34 miles to 1 gallon. Okay, so for every 34 miles traveled, 1 gallon of fuel is used. And therefore, we have to ask ourselves, when the car travels 4,250 miles, how many gallons does that use? Okay, and we can think about this as an equivalent ratio, because the ratio of 4,250 to the number of gallons used should equal 34 to 1. It should be equivalent ratios to each other. So how do we get from 34 So 4,250. Well, we have to multiply by something. And what is that something? Well, we can find out what it is by dividing 4,250 by 34. So let's do that. And we get 125. Okay, so we therefore know that we need to multiply, going to make this a little bit smaller, by 125 on both sides. And so if we do that over here, oh, I didn't get the other bit, but you get the idea. Imagine that's times. What will we get? Well, obviously 1 times anything is just itself. So 1 times 125 is 125. And therefore, the number of gallons used per month is 125 gallons per month. And then we times that by 12 to get gallons per year. Now, that's one way to think about it. Now, that is a bit of a long way to think about it, but it does work. And if you're not confident thinking it all through in your head yet, and you want something a bit safer and a bit easier to deal with, I would recommend setting it out this way. Because even if it takes a little bit of time, at least you know you've done it correctly. So this kind of thinking of it as a ratio way can be really helpful. The other way to think of it is that we know that every 34 miles, so this is the second way, is the way that I explained it for that previous question that we looked at. For every 34 miles traveled, 1 gallon of fuel is used. And so we want to know how many gallons will be used in 4,250 miles. So we just need to know how many 34s there are in 4,250. Because if we know how many 34s there are in 450, we'll know how many times it used up 1 gallon, and that will tell us how many gallons it used. So therefore, we do 4,250 divided by 34, which gives us 125. So either way, we get the fact that it's 125 gallons per month. Then we just times that by 12, and we get gallons per year, because there's 12 months in a year, and we get 1,500. So that is the answer. Okay, hopefully that makes sense. So the next question is going to be this one. So let me just move on the Menti. Okay, great. So off you go. I'll give you 2 minutes again. Okay, 30 seconds. Okay, so the correct answer is C. Okay, so let's go through how to do this one. Let's put this over here. Let's get this one back. Okay, so let's make this small. Okay, so what's the ratio of cost of a Tabor to a Volvo to an X-Tam? Okay, and we have the cost to purchase for each car. So we're just interested in this column here. Everything else we can ignore. Okay, so first of all, it's a good idea to just write down what ratio they're asking you for. So we're looking for T to V to X. Okay, and the numbers that we have, the cost to purchase a Tabor is £12,500. The Volvo is £37,500, and the X-Tam is £62,500. Okay, so let's just get that over here. So we have three items in our ratio, so we can't just put it into the calculator and get it to simplify the ratio for us. So what we need to do is look for common factors, and it might not be obvious how to do this. So there's a few different strategies that we can use. One thing that you can just do is try dividing them all by the smallest number, okay? Because that often will help, even if it doesn't immediately get you the answer. So in this case, obviously 12,500 divided by itself is just 1. So we get 1. 37,500 divided by 12,500 turns out to be 3. So that's good because we've got a whole number. And 62,500 divided by 12,500 turns out to be 5. And so that actually works out pretty well because we get to the answer. Now, so that's it. So we know the answer then is C. Now, dividing them all by the smallest number won't always get you directly to the answer, because it won't always give you whole numbers. Sometimes it might give you like 1 to 2.5 to 7 or something, but it gets you close to the answer. And in this case, it actually gets us all the way to the answer. Let's think about some other ways we could have done this. So what we could do is just look for any common factor that they all have, that we know they all have, and divide by that. So the first thing is we know they're all multiples of 100 because they all got 0, 0 in the end. So we can just get rid of those zeros, which is a less precise way of saying divide them all by 100. So that makes them a bit easier to deal with. Okay, we can also see that they're all multiples of 5 because they all end in 5, and any number that ends in 0 or 5 is a multiple of 5. So we can just divide them all by 5. We get 25. Whoops. 375 divided by 5 is 75. And 625 divided by 5 is 125. Now at this point you might spot that they're all multiples of 25, but if you didn't, well, you could see, well, they're still multiples of 5 because they all end in 5, so we divide by 5 again. 25 divided by 5 is 5. $75 divided by 5 is 15. So we get 15. Whoopsie. And 125 divided by 5 is 25. And again, we can see that they're all multiples of 5 because they're all in 5, so we'll divide by 5 again. So 5 divided by 5 is, of course, 1. 15 divided by 5 is 3. And 25 divided by 5 we already did previously, and that is 5. So we get to the answer eventually. And we can tell this is the answer because we've got a 1. So you're not going to be able to simplify anything when you've got a 1. And also they're all prime numbers. Okay, so it took us a few more steps, but we got there in the end. So you can try dividing everything by the smallest number. That will often get you the answer or close to the answer. Or you can just find any common factors and just keep dividing everything through by common factors until you can't anymore. And because it's multiple choice, we know, okay, we've got one of the answers. So that also helps to know that you've finished. Okay, so let's quickly do one more question. Okay, so 2 minutes, off you go. And I'll move the Menti on. Yep, off you go. Okay, so I am going to go through this one really quickly. I know it is 5:25, but I just want to make sure we go through this last question. So, legal sector spending on IT hardware, IT software, and IT consulting are all set to increase by the same amounts in year 6 as they did from year 4 to year 5. Assuming this is the case, what is the total legal sector spend in year 6 on all 3 IT areas combined? Okay, so this table here is about income, and this one here is about spending. So we want this one at the top, this graph. And it tells us we need the data from year 4 and year 5. So we only care about these 6 bars here. And we need to work out what are they going to be in year 6. So just real quick, we are told that the increase will be the same as it was. So, the increase from year 5 to year 6 will be the same as it was from year 4 to year 5. So if we just zoom in a second, we can see that for hardware, which is the red line, the increase was from 40 to 45. So it went up by 5. So if it increases by the same amount again, it will be 50. this is million pounds. For software, it went up from 25 to 30, so that's an increase of 5. So if it goes up by the same again, it'll be 35. And for consulting, it went up from 15 to 20, so it went up by 5 as well, and therefore it's going to go up by the same amount again, and we'll get 25. Okay, so to find the total spend, we just have to add those three together, and 50 plus 30 plus 25 is 110 million pounds. So the answer is E. Okay, so we'll finish there, and obviously that's our last session. So I just want to say thank you all for coming to these sessions. It would have been a lot less fun for me if you didn't. And yeah, I hope you found it helpful. And yeah, I hope you all believe that you can do really well in these numerical reasoning tests. It is just